All right, hello and welcome to Change Notice Unsnapped. We're gonna wait a few minutes while people pile in, but I'm Tobias, joined here by Chris.
Hey, how's it going?
We're excited to bring you what I've been dubbing it Shark Week. It hasn't really caught on yet, but we're tearing down the shark vacuum.
I think during actual Shark Week, we can replay this episode and get a lot more coverage.
That's perfect. We'll pass that off to the marketing team. Does anyone actually know when Shark Week is? Let us know. Let us know in the comments, because I don't actually know. Let's while we're waiting here. So what I'm really excited about the vacuum, it's one of the most moving parts in a device that we've actually torn down, which is very different than like the Sonos speaker that we did or the Nest doorbell. So let's talk about, for anyone here while we're waiting, first make sure on your chat, make sure you're posting to everyone. So in the bottom right, switch that little drop down to everyone. Let us know where you're from and what is the first mechanical moving part that you worked on. Any type of moving parts or mechanisms, post it down in the chat. And yeah, Chris, what about you, Chris?
Yeah, I mean, this robot, taking this apart took me back to my college days when I was doing some mechatronics classes, and we were doing a bunch of, we basically were making robots that had to move, follow IR tracks and things like that. Very similar, although probably at a much more DIY kind of scale. But yeah, we had little prompts from the professor to make a little shooting robot or something like that. What about you?
I actually forgot about that. I do remember making a robot, a little car that followed some black electrical tape around a circle on a ground. But the most memorable one, this was a little bit later, the first project that I worked on at Apple was Touch ID on the iPhone 5S. And we were working on the tact switch. And I remember we had a huge issue at some point during the ramp where the tact switch buttons, they didn't sound right to some of the industrial design team. And we had to quantify, all right, it doesn't sound right, it doesn't feel right, the button on your iPhone. And again, there's only a couple moving parts in the iPhone. There's like the home button, the volume switch, and the power switch. So we had to quantify we were using an Instron force displacement tester to quantify that little dome switch, the depression, and what was different about the ones that didn't feel right and sound right versus the nominal ones.
What did you have to do, some kind of force, like the detent ratio or the snap ratio, and make sure those things were
exactly
more consistent?
We had some standard metrics, but we were defining new metrics to try to quantify, exactly the detent curve, for what a good button felt like.
Nice.
So way too much time spent on that one little dome switch there.
Well, it was all worth it, because I remember playing with those buttons, and that's the perfect snap ratio.
There was, a lot was said about the click feel of the iPhone button. Things that you can't really put in spec sheets, but
yes,
spent a lot of time on. Let's see. So again, welcome everyone else. Julian cannot hear audio. Can anyone else confirm that they can hear our audio? I think it might just be you, Julian. All right. Thank you, Michael. Let's go ahead and get started. I think we've got enough people filing in now. So welcome to Change Notice Unsnapped. This is our weekly video podcast where we discuss all things electronic, supply chain, manufacturing. It's hosted by experienced product design engineers, mechanical engineers, and our goal is to build a community for knowledge sharing, support, and continuous improvement. Normally, these events are run by our CEO, Anna, but today's special Unsnapped edition is hosted by myself. I'm Tobias, and joined here by Chris.
How's it going?
And a few exciting announcements here to kick us off. First of all, comments down on the right, please tell us where you're from and make sure it's posting to everyone and not just panelists, and tell us the first moving mechanical part that you worked on. And exciting follow-up from last week. Actually, a couple weeks ago, we had a teardown of the Nest doorbell, and we had a raffle to give away a Nest doorbell. And so we're excited to announce the winner from last time is Chris Rill from We Build Hardware. And we're going to be sending that Nest doorbell to them. And he also is the reason he recommended we tear down one of these robot vacuums. And so that's why we're tearing this down today. So if you want a chance to win one of these vacuums, we're doing the same thing today. Fill out that survey at the end. Let us know what you want us to tear down, and you'll be entered in a chance to win this wonderful vacuum. All right, a few more things before we get into the teardown. We have a couple more exciting events coming up. So today we're doing the vacuum. On November 4th, we're doing the Blue Yeti microphone. That's the big podcast microphone that everybody has. And we're actually going to be joined by Adam Bennett, who was the lead mechanical engineer at Logitech, recently acquired Blue microphones. So we're really excited for that. And we have another event later in October that Anna is going to be hosting. So stay tuned for that. Let's kick off some intros. So Chris, you want to introduce yourself?
Yeah, my name is Chris, mechanical designer, mechanical engineer. Used to work at Amazon and a couple of startups and doing some consulting on the side. So yeah, been pretty exciting to take this device apart and see. This is, I've never built something this large, so it's been really interesting to open this one up. And how about you, Tobias?
All right, thanks, Chris. I'm Tobias, background in mechanical engineering, product design, worked back at Apple for about 6 years, iPhone and Apple Watch, lots of sensors, touch screens, health sensors, and yeah, excited to be tearing down this vacuum today. And excited for everyone joining us here. I see a couple of our regulars. Michael Lowe, welcome back. To all the newcomers, welcome as well. We've got an exciting session. Just a little preview of what we're going to dive into. So we're going to do this live teardown of the vacuum. We're going to discuss some of the design decisions made, and then we'll actually have a Q&A at the end as well. It can be off the record. And we've got some x-rays of this device as well, thanks to our friends at Creative Electron. So with that, let's go ahead and dive in.
All right, I'm gonna go ahead and share my screen. You might notice I'm in a different location because this robot vacuum was too large to put on my regular desk. So I'm at my dining room table. And here it is. So this is the Shark robot, I think is an Ion Robot 750. And this thing is about I think a little more than a foot in diameter. And, this is from all the different sides. There's a couple of, let's see if you can see, there's like some sensors. There's this bumper actuator that when it runs into different elements of your furniture, it can change direction. So it can be hit from the side, either side, or from above. Let's see, there's this removable bin. So this is where all the junk that you vacuum up goes. Open this up. Maybe. So you can see inside there's a good filter, prevents the stuff from the dirt and dust from getting into the rest of the robot, hopefully. And there's that. On the underside, let's see. We got these kind of spring-loaded wheels. You can kind of hear some, I don't know if you can kind of hear it, but there's some detents when it kind of goes down. And there's a bunch of sensors around the outside. Looks like the way this works is these front things kind of spin, go against these brushes here, and then direct all the dirt and dust into this main brush here, which then goes into that bin that we talked about earlier. There's a couple of charging pads here. You might notice there's a dock. So this device can kind of find its way home. If I see if I can push the dock, it can actually, oh, maybe it needs to have its bin in place. But then it can kind of move its way to the dock.
Look at that. I'm really curious here and would love the audience's feedback. What types of sensors and mechanisms do you think guide this robot? Chris pointed out that it looks like that bumper on the front actuates when it hits a wall. I know, there's a wide variety of these different robot vacuums, a whole bunch of different sensors on them. How do you think they're actually determining, when you're hitting a wall, when you're close to a wall, how to not fall off the stairs? I want to see the votes. So post them down in the comments, and also how it actually found the dock there, because that was pretty cool.
Yeah. I think one of the other announcements that came out recently was Amazon created their own robot, I think. So there's been a renewed interest in these robot type devices for the home. And yeah, they touted the ability for it not to fall down the stairs. So I think robot vacuums fall into that same category. Yeah. So I guess I'm going to go ahead and get started. Is there any, as Tobias mentioned, if you have any ideas or thoughts on how this works, please put that in there. Otherwise, I'm going to get going. This is basically a big mechanical bin, so I'm going to move that aside and then we'll get to the more interesting parts here. The first thing I'm going to do is take off the battery door. This is the only user accessible kind of screw that you can take apart. Just uses a regular Phillips screw. Everything else is a Torx screw, and that's because this is a replaceable battery. So they have these convenient little pull handles, and then you can.
How big is that battery there compared to some of the other things we looked at, like the Nest doorbell last time, or some of the cell phones these days?
Yeah, so if you look at this, the capacity rating here is 2550 milliamp hours, which doesn't sound like that much, but then you realize this is actually coming in at 14.5 volts. So it has a 35.6 watt hour capacity, which is pretty good. I mean, this should last for a good hour, maybe hour or two of runtime, and then it, hopefully the device will find its way back to the dock to recharge. But when you compare that to, I think the Nest doorbell had a 6,000 milliamp hour at 3 volts. So something like, what is that? I can't do the math. What, 18 watt hours maybe. So I think this is a little bit beefier, and they're kind of taking advantage of the size. So you can get a really much thicker and wider battery than you would normally get on a smaller consumer electronic device. I'm going to take off this brush cover and this brush itself, which is kind of an interesting torsional helix kind of style here, to get into the rest of this. Let's see. If you'll notice, they actually kind of modularize these wheels. So the wheels are actually replaceable, so you don't have to take apart the whole device if something gets stuck in the wheel. And they're kind of these spring-loaded, as we mentioned earlier. There are actually 5 Torx T15 screws that hold it in place. I'm going to go ahead and take those apart. I've actually unscrewed a few of these just because there were so many screws in this. We wanted to save you guys that the pain of watching me just unscrew a bunch of screws.
And Chris, are those self-tapping straight into the plastic, or are those screwing into a nut on the other side?
These are self-tapping screws that are going straight into plastic, I believe. So you can kind of take a look. There's getting a bunch of little black plastic bits onto my nice white tablecloth here. Let's see. There it goes. So I can take this wheel out, and I believe there's a little connector here. Let me just get it from this side. There we go. So this is the wheel, one wheel assembly. It comes with its own motor, and there's a spring. So this action here, you can kind of see it. The spring, it's a spring-loaded mechanism. There's something here that must be pressing on somewhere inside the device. I think if this robot kind of comes off the track or goes over the edge of something, the wheels stop turning. So that must be something that they were concerned about. I'll take this other one off.
Russell's got some hypotheses on how this robot is avoiding walls, prox sensors, mechanical switches for the bumper sensors. I think those are some good guesses. We'll have to take it apart and see.
Yep. Okay, did I get all of them?
We've also got some recommendations here. We should get some electric screwdrivers to speed up some of the screw removal. I know we've been partnering with iFixit, so normally we're using their kits. I don't actually know, does iFixit have any electric screwdrivers? If anyone from iFixit is on, let us know if you guys have electric screwdrivers. We've been using the manual ones because that's what we're used to.
Yeah. And okay, something is getting cut in here, I think. Let's see.
That's kind of nice that they have the modular wheels.
Yeah.
I think that's, my guess would be that's like you said, easy to repair if either the motor burns out, or I know we were talking earlier about hair or gunk getting stuck in these wheels.
Yeah.
To just completely clog up and get stuck. Being able to just swap one out, that's kind of a nice touch for repairability.
Right, got the other motor out, very similar, just a kind of reverse. And it looks like these brushes are also replaceable in there. So if these get gunked up, you can quickly replace those as well, which is pretty cool. They've done a good job of figuring out where the potential failure points are and getting these going. I had some trouble with that connector, but looks like everything's okay. Let's see, the next part I think I have to take off is this bumper itself. I've taken out a couple of these screws, but this way we can, because I think this the cover is captured by this bumper.
Let us know in the comments as well any questions that you have or any areas you want us to dig into. We love to hear from the audience about what you're most interested in, and we can do a deep dive on that.
Also, one thing that could be interesting is we can count how many motors there are in this device. So I think the previous device that we took apart that had motors in it was the game controller from the PS5, and that had, I think, 4 motors in it. So we'll take a look.
I think we might top that here.
So here's another, this is just a cover here. Got a couple little brushes on that. And there it goes. So this is looks like there's a couple of different types of plastic in this. There's like an IR window, kind of relatively shiny and clear, and then a plastic frame on the outside of that. Let's see here. Yeah, so if I now, I think there's one more screw I can take out. Maybe 3 screws here. Get inside of this. Yeah, and I couldn't use the actual iFixit kit because of how deep some of these screws are. Like this one here is pretty far down. So I had to buy a special kit from Amazon of just new screws, a new screwdriver. You can see there's the charging pad here that I'm kind of obscuring as I unscrew this. And There's
We've
this.
got yeah, we've got a few good questions coming in.
Oh yeah.
From Jason and Julian. We can keep going. Just I don't think we can see it yet. One note for Jason and Julian: make sure you switch your comments to everyone so that other people in the audience can help answer as well. Any sign of design intended to reduce noise, as some of the older Roombas are quite loud? Let's take a look inside. My guess would be the loudest component is actually the rotor for the suction. And so we can take a look inside of there to see if there's anything that looks like it's intended to reduce noise. That's a good call out.
Yeah, that's a good question. I don't see too much damping material in this, but this is the main board, and I think it's a little hard to get to see this. Maybe we can switch to instrumental where you get a closer look at that board. What do you think, Tobias?
Yeah, let's dive in. We're looking at some of the insights now. All right, so here we are live in the instrumental app. Again, for those not familiar, typically in this app, we have data from all of your production units. We've got AI running to help you guys find new issues, fix them faster, and do all this remotely. Right now, we just have one unit in here, and we're just using this as a really easy way to navigate high-res images of the teardown. And also a reminder, if you want access to this, we can actually get you guys access to this full teardown library. And you can see we've got the Nest doorbell from last week. We've got the Sonos One PS5 controller. So in the survey at the end, I think there should be an option, or you can always just reach out to communications at Instrumental. Let's dive in on what Chris has here. So he just took off the top. Looks like we have one main PCB here that's housing most of the components. My first reaction here is, wow, that's a lot of connectors. Yeah. It looks like we have a lot of these kind of ribbon connectors, various sizes, and it looks like most of these are either going to sensors or a few of these going off to the motors. We can't actually see any of the sensors quite yet. I think we'll have to go one layer deeper. Mm-hmm. But a few interesting things to point out here. We've got the LEDs, which line up with, I think, that top that you took off.
Yep.
If we look back at the top, where did our top go? Top inside here.
Oh yeah, like when I turn on, there's this 3 sort of battery indicator lights. I think the charging lights maybe.
Yeah, I think those 3 are light pipes right there. Yep. And then we've got 2 other indicators, looks like maybe for Wi-Fi and an air connection. And looks like a Wi-Fi module. What do you think, Chris? Located over the shield can?
Yes, this device is supposed to integrate with Amazon. I won't say her name just because I have one in the room here, but I think you all know who I'm talking about. But you can ask Amazon to, I think, clean your room or schedule something. But yeah, it looks like it's an integrated Wi-Fi module. I think I see an antenna on the bottom edge of that board. That looks like a separate module that's just soldered on top.
Yeah, I think that's a good hypothesis. What do you think? So looking at all these connectors, this looks like a pretty difficult wire routing design exercise here. Yeah. I'm also noticing the little red marks between the receptacle and the plug. I have some thoughts, but what do you think, Chris, is the intent of these?
Yeah, that's a good question. I mean, I think because there are so many reused parts, so like there's a bunch of these cliff sensors that they call them, because this device could approach the edge of a staircase at any angle. So maybe there's some issue with telling which sensor goes to which connector, just because there's so many of them. And it looks like they're all very similar shape and size. There may be slightly different number of wires, but I can imagine it would be pretty tough for a technician to get them all right all the time. So there might be something to do with like placement. I don't know. What do you think?
It could be placement. I've also seen as a safeguard to make sure the connectors don't come loose over time. So the operator will plug it in, they'll mark it, and that is where it was at time 0. And then later on, if you see a gap, then that indicates that there's been some movement over time. I've seen that with screws too. A lot of times they'll do that with clocking a little blue line across. So it could be a safeguard against connectors coming loose. We've also got, here are attack switches for the buttons, another LED, and then it looks like the ARM processing unit over here. And yeah, I'm really excited to figure out what sensors they're using, but I think they're hidden just under here. We can look briefly at the bottom side before we go back to tearing down further. So here we have the top, flipping it over to the bottom. It looks like we have sensors that Chris pointed out around the edge. I see 4 of them here. 1, 2, 3, 4. I've got a thought. I want to hear feedback from the audience. What kind of sensors you think these are? Post in the comments. I think, especially looking at this black divider in the middle, I think this is a proximity sensor with 1 emitter and 1 receiver. So a little IR emitter and receiver. And I believe these are pointed down. So these are not going to sense walls. These are just going to be to make sure it doesn't go off the edge.
Yeah, I think that sounds about right. I don't know if we can get a closer look at those maybe later.
Yeah,
it looks like there's a little spring in the front there. Is like that's keeping the bumper pushed out. And that's maybe why it has to be captured around the top and bottom housings of this, which is interesting as well.
Let's hop back and take it down a step further and see what of the sensors are actually preventing it from hitting the wall.
All right, so I got this here. I'm trying to figure out what the next right step is. I might actually go ahead and take off all of these wires since they have those markings. Maybe I'll be okay and I won't lose them. Let's see. Let's take out a bunch of these.
All right, good news, Chris. Our friends at iFixit say they do actually have these deep recessed drivers.
Oh, excellent.
And so next time he's going to hook us up so we don't have to buy these off-brand ones. We can stay on brand.
All right.
But the electric screwdriver still not here yet from iFixit. Maybe
that was a new free product idea from the audience.
Yeah. All right, let us know again if there's anything specific you want us to dive into during this teardown. Right now, I really want to see all the different sensors, if they are just the prox sensors pointed down, or if there's something else on the front.
So finally removed all the cables there. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 connectors, which is pretty significant. So that's 12 different wire harnesses and wire wraps that need to exist. Okay, so I think I'm going to start by taking this piece off, maybe.
Julian had a good question about, is the red, I'm assuming you're talking about the red lines on those connectors, a warranty seal. I don't think that mark is a warranty seal, because I don't think it actually gets destroyed when you remove it. Typically the warranty seals are some type of sticker that cannot be repaired. I think those
Yep.
red ones were probably more for assembly reasons that Chris and I were talking about. But that's my hypothesis. If anyone else has other opinions, post them down in the chat.
Yeah, I think I mean, it's a good idea. It's a good thought. Looks like I might have to take the larger screws off as well. But because these things probably do fail fairly often, I imagine vacuum technicians actually get in here fairly often to replace and dust off certain parts. So I think it's more of an ease of assembly kind of thing. Actually, one thing I was noticing, which is interesting, you can see there's, maybe I can zoom in here a little bit. There's a couple of these, looks like kind of sensors that are facing out in different parts of this device. And this product, I think, is part of a family of robot vacuums, because this is a really interesting shape. So there might be some places here that, like on a higher end model, might have even more sensors. But this one being maybe on the slightly lower end doesn't quite have that many. So it's kind of interesting to see how, you know, they just built in that capability and they can reuse these parts, kind of like a family.
Do you have the, yeah, Chris, I remember on mine on the front side, way around almost at 3 and 9 o'clock, it almost looked like there were, yeah, right there. It looks like there's a sensor there as well, which we can dig into. It looks like 2 windows, so maybe that's another prox sensor.
Yeah, let's see. I think I can open up 1 or 2 of these things. Let's see.
Is there anything in there?
This one has a screw. Yeah, there's this, looks like a little window here. It's got its own top and bottom. This one actually has nothing attached to it. So yeah, maybe this is indeed the cheaper one, and there's a couple of fancier ones out there.
That's really interesting. Yeah, so I bet you're right. I bet they're using the same enclosure across multiple SKUs. And this one, they decided just to keep in that lens, and maybe in some of the other models, they have additional prox sensors on the side there.
Yep.
It's an efficient decision for them to use that. Again, a lot of companies have multiple SKUs here. We're seeing that more and more, actually, even within our customers, is beyond just one SKU that you're building thousands or millions. You have a lot of different configurations, and it's actually something that Instrumental just released as software support to easily and automatically switch between different SKUs on the same manufacturing line. So we're pretty excited about that. Our customers are pretty excited.
Yeah, I think that will be really helpful for a bunch of things. So you don't need quite as many devices if like you have the same board, but like 3 different colors. You don't have to, you can use multiple, you can aggregate all the information from all those different configurations. All right, I think I'm finally almost able to take this device out. Nope, I'm missing something. Oh, there's a couple screws in the middle of the board.
Are those also, I noticed some of those are Phillips, but some of them are the Torx. I think the exterior ones were Torx. Why do you think they use the Torx on the outside?
Yeah, I mean, I think we briefly mentioned it. I think they wanted the user accessible one, like the battery, to be a regular Phillips, because most people have those, whereas the Torx are a little bit more specialized. So just opening up the rest of the product is probably discouraged unless you're a technician. But once you're inside, they make it easier. I think it also helps you to identify which screws go where. So, you know, like inside is going to be more Phillips and outside is going to be more of the Torx. So there you go. I got the board out. And maybe this could be another good point where you can go underneath and I can take this part out while you're doing that. There's some really interesting mechanisms here before I switch over, but you can see there's these little bars that kind of go in and out, up and down. So maybe we can take a closer look at that.
Yeah, that's really interesting. Let's take a look. Those are not the tact switches that I was expecting to see there.
Yeah.
Let's hop in back to the close-up. So we've got this torn down a couple more steps here. Let's go straight to the PCB. So he took off the front bumper, and again, we're looking at, as this thing rams into the wall, that bumper either actuates in XY to hit something. And I think it also actuates in Z a little bit.
Yeah, I think these go up and down. There's springs underneath this, I can see. So that might be.
Yeah, what it looks like, again, looking at my one in person here, it looks like this plastic rod actuates up and down. And I would have thought that there would just be a tact switch that it would run into that would limit it. But I think this is actually a little IR brake beam sensor that it triggers as it presses down, and the spring is independent here on the rod.
Yep.
Which is an interesting design choice. Why do you think they use that instead of a tact switch?
Yeah, that's really good. I mean, I actually kind of coming back to your story about the detent force from your iPhone days. Maybe that's something they just didn't want to do, just in case, you know, your robot vacuum is about to go over something, but then it kind of gets stuck or caught. So this free movement allows them to just detect if something is hitting that bumper. I don't know. What do you think?
I think it's probably I think that's probably the correct hypothesis. In terms of like design complexity, I would think that the detent switch would probably be the easiest and probably comparable price. So I think it has to be, they want an extremely low force to still be able to trigger that. And they didn't want to have to deal with detents, you know, switches not getting fully triggered or any type of force, because really you want it to just be a tiny bit of force from hitting the wall or hitting something. And I think this probably achieves that in the simplest way.
Yeah, I think you also don't have maybe potential mechanical failures in this particular way as well. Like if a robot really slams into something, maybe you could damage a dome. Whereas with an IR brake beam, it just breaks the beam. But yeah, that's really interesting.
We got a question from Karsten on why is this PCB so jagged? I was asking this earlier too. This is a funky shaped PCB exterior. Looking at what the alignment features are, because a lot of it about how is this PCB aligned into the main housing, because there are sensors that we'll find, both these switches here and some of these other sensors that interact with the exterior. So we do need some alignment. It looks to me like it's actually these external features that are used for alignment instead of some of the interior. There are some interior posts and through holes, but it looks like those might be clearance holes that's just floating around. And then it's actually using this exterior to datum. Best guess here is because the critical alignment is from the PCB to that exterior, because that's where the sensors are. And the easiest way that they found was just to datum kind of an XY in this jagged fashion. What do you think, Chris?
Yeah, I think that's as good an explanation as any. Otherwise, I was also thinking maybe in terms of routing the board, maybe like physically routing it, like once they cut it out, maybe it's easier to go with straight lines than sort of the I don't know if this is an exact semicircle or circle. So maybe there's something with the way that's manufactured as well.
Mm. Yeah, that's a good point. Lines are likely a little bit cheaper, even though it makes it, look a little more complex.
Yeah.
I love this from Chris. It could be a nod to a shark's mouth, an open shark's mouth. That's a great one. All right. So we've got the sensors here. The ones we still haven't found what causes the XY sensors to actually trigger. So looking at the back, so we do have these two tact switches here. I think these are for the wheels. Is that right, Chris? That first part that you took off is actually hitting these wheels to detect when they're up or down.
I think you're right. Yeah, these there's like that mechanism. I think, like you said earlier, I think we talked earlier. There's like a little clicking sound when these wheels pop up. So maybe when it's in its down position, the wheels are like, either way, it's like a dead man switch, right? They basically want to be down all the time unless they're not down anymore. And so when the wheels come up, maybe that triggers a signal to say, okay, don't stop turning all the motors. But yeah, that's a really easy way for them to just detect if the wheel's in place or not.
Yeah, I think so. Those are the switches for the wheels. Let's just hop over. Were you able to get this bottom part off, Chris?
Not yet, but I will work on that, I think.
To pop that off, because we know there are, so we have the IR prox sensors that are pointing down. I think they're calling those the cliff sensors. And we have some type of sensors that are going through the IR window. We can hop over. I think I have it here. All right, okay. So this is after we take the top off.
Oh yeah, that's better.
And so if we look at the bottom, so here we have on the bottom, we have two more of these IR brake beam. Can you see, Chris, where I think that's the bumper from the top that's actually sensing any X movement and breaking that beam. But then we also have, it looks like 4 of these little sensors.
Mm-hmm.
And these are actually different from these are, looks like IR sensors. These are different from the other IR prox sensors that are facing down. Looks like just one module. I think these are passive IR sensors instead of the emitter and the receiver. And yep. This reminds me of actually back on the Nest doorbell, we had similar, let's see, where was the IR sensor? We had one right here. So again, similar passive IR sensor. This one looks like it has maybe 4 or 5 of them pointed outwards there. We can see from the side view too, they're kind of pointed out all around here. And they're encased in this little metal as well, which is interesting. I guess maybe making them a little more robust.
Yeah, I mean, one thing that strikes me, like this one has a lot more sensors than that Nest doorbell, and yet these two products can almost be found for the same price. So there's it's a really interesting to see how much, bigger this product is, how much more mechanical stuff there is, and yet, similar feature for feature. And that one is so much smaller, they have paying less shipping costs, less material costs. I guess really comes down to that electrical system and how complex it is to maybe cram things in.
Yeah, that's a really good point. What I've found, which I think is universally fairly accurate, is the smaller you make the device, the more stuff you need to cram into a smaller form factor, it becomes exponentially more difficult. to fit all that stuff in. So going from a robot vacuum where you have a little bit more room, less size constraints, to a doorbell, a mobile phone, miniaturizing all of that, routing, sensors, batteries, it just becomes exponentially more expensive. So I think that could be why, again, they're able to cram a lot of stuff. There's a lot of motors, a lot of sensors in this device. Whereas, something like the Nest, you have to spend a lot of time cramming all of that into a small form factor.
I think that's one of the fascinating things about product design is just how all the different trade-offs like these companies are making to provide something out there at a price point that's well, that's a good point. Chris is saying don't discount the service revenue from the doorbell. Maybe there's some additional revenue that's being included.
All right, we're getting almost down to the bare bones here. Let's hop the few more things that I wanted to see is actually take a close-up look at those cliff sensors, the IR sensors that are pointed down.
Yeah.
And then maybe look at some of those motors, and we can take a look at the X-rays as well from Creative Electron.
That sounds great.
And then it's really up to the audience on if there's anything else you want us to dive into. We've got this thing gutted now. We can go in any direction. So let us know. Do you want to look at more motors? Do we want to look a little closer at the sensors? Were you able to get one of the sensors out there to look at those box sensors?
Well, I think, well, you can probably see this one right here. So that's one of the exposed ones. I did take this side off, but yeah, there's a couple here. So they just look like this. And then I think there's two in the middle that are kind of hidden a little behind.
Oh, yeah.
But yeah, I can go ahead and get started the rest of this. So I think we had the motor count. We had 2 for the wheels. Looks like there's a third one here. That must be for the main brush. I think there's like a mechanism that attaches to here. So it's like a drivetrain. And then there's these 2 motors, I think, for these little sweepers in the front. So that's 5. And there must be one for this, for the actual vacuum part as well. So that's 6 motors. I think this takes the motor crown for us here. I guess why don't I take this main vacuum motor out, or the vacuum module.
Oh, Patrick has a good question. Are there any dustbin sensors? Feature-wise, I'm not actually sure if this Shark has a dustbin sensor. We'd have to read up on the manual, but we can look. You could look in the dustbin, Chris, if you see anything. I didn't see any sensors in the dustbin myself. Let me pull out mine here.
I don't see any sensors here, although the device did refuse to move when I tried to dock it without this thing. So they might be just using the weight as a, like from those wheels. So those wheels weren't being detected. But I don't actually see any kind of sensor in that. Pull out this. Okay, so yep, we were right. There's another motor in this. And it looks like this can actually be taken apart. So I can take a look at that one. In addition, I can take out, looks like this one has a bit of a, looks like I can take this motor module out as well. What's great is actually each of these motor modules does seem to be removable and replaceable. So they were definitely thinking about how to service this product in case any of these motors failed.
So that's the rotary brush motor right there, correct?
Yes, I believe so. Just wiggle it out a little bit. Oh, I think there is a, turn this over. I think it has to fit, So this is it's kind of a square drive here, and I think it has to fit perfectly, otherwise it won't come out. Push that. There we are. Oof, all right. I can open this up a little bit further here.
Yeah, if you want to open those up, I've actually got some images if we want to dive down inside of those in our last few minutes here.
Okay.
Do we want to go survey from the audience here? Do we want to go inside the vacuum motor or the brush motor first? Let's go into the vacuum motor because we had some questions about sound damping.
Okay.
You got that one open there. Let's pop that one open.
Here's the vacuum motor. Looks like this is snapped on in addition to this screw.
Was there another screw on there that we need to pop off? What is that?
Oh, and there's like a little rubber grommet here that holds it together. A couple of these. There we are. Missing one more rubber grommet. All right. So I don't know again if we can get too much further in here.
What is that white mark on the fan blade there?
There's like a little arrow inside of it. I wonder if this is like an alignment arrow, like you were talking about earlier. Maybe this is how they align this motor in there. It looks like that was intentionally added, some kind of indicator. This motor is interesting in that, well, there's a bunch of like pins that kind of define how it spins, or I don't know this. I don't know if you can really see this, but some of these are missing entirely on mine. I don't know if you can see the difference between that.
Yeah, that's really interesting. I saw that on mine as well.
There you go.
I'm wondering, just thought of this hypothesis here. I wonder if it's a weight distribution and they somehow, Anders has the same idea here to calibrate the balance of the motor. They'll do it in the factory and then they'll break off a few of these to balance it, almost like they do on car tires. Sometimes they add on little weights around the rim to balance it. That's pretty cool because this thing is going to be moving at pretty high RPMs and you don't want it to be rattling or shaking at all because that'll be inefficient.
Yeah, that's really fascinating. That's pretty cool inside then. I don't know that. I think this is kind of sealed on there. I think these are heat stakes. I'm not sure I can break into this any further. The other one I can look at though is this. Looks like this is the main brush motor, and look at that. There's like it's like a drivetrain here, which has with a real belt. That's an actual belt in there, which is really cool. Yeah. So if I spin it one way, you can get the belt to actually move the gear on the directly tied to the motor.
Cool. Let's hop into, before we turn it over to open Q&A, let's take a look at the X-rays of the device here, because those are always fun to look at. And for anyone that wants access again, we can get you guys access to this full teardown library, and we go all the way down into the board level. We've got these images that Chris looked at of this drivetrain, which is pretty cool. And then the prox sensors that they have branded here, the cliff sensors, which are the ones pointed down to make sure you don't fall off a cliff. But let's look at, we've got X-rays here. Let's look here. So this was a pretty big device. So we zoomed in actually, or rather our partners over at Creative Electron zoomed in, and we actually have these higher res of a couple different areas. So we can look around the outside. So this is on the front left. You can see this is the spring for the wheel. I believe this here is one of the cliff sensor modules.
Yeah, it looks like that has a board or something, right?
Yeah, it looks like a small PCB and then 2 sensors. My guess is 1 emitter and 1 receiver for a small prox sensor.
That makes sense.
Let's see. Then this is I think this is the brush motor here.
Yep.
Flipping through. Let's see. Here's on the main board. Pretty cool. You can see. I think this is the wheel on the bottom. Oh, yeah, this is pretty cool. Here are the
sensors.
Here are the procs. So I think these are on top. We've got those 2 front-facing procs.
Yeah.
And here are 2 more of the cliff sensors pointed down. Again, over on the right side. And then this is on the bottom left. We actually have another little prox down there. And this one's pretty cool just because you can get a glimpse inside of the motor. You can actually see some of those windings there, which is pretty cool. I just love how the X-ray reveals everything that's going on inside the device. And you can see the complexity of all this wire routing too.
Yeah, I mean, I guess, one advantage this device has is that it's basically made from entirely plastic. So all the metal shows up when you're doing the X-rays. It's also great for Wi-Fi because you can have great connectivity no matter what thing is, what orientation the device is in. It looks like we had a comment from Andrew regarding the XY prox sensors or lack thereof. Looks like SN. Is that serial number? No. What is that? Might be
Shark Ninja.
Oh, Shark Ninja might be using the bumpers in conjunction with a random bounce algorithm.
I like it.
So that makes sense.
Yeah, and the one other thing that we didn't touch on is how does it actually find that base station? Because at the start when you hit dock, it actually rotated around and found the base station. I've got maybe a few thoughts on some of those other sensors, but want to hear everyone's guess first. So post it in the comments. I think we've reached a good point on the teardown here, where we're actually going to flip over to off the record live Q&A. So for anyone joining the recording, thank you for joining. And I will go ahead and if the powers that be can stop recording here, we can open it up for live Q&A.
Manufacturing is changing, and keeping programs agile and on schedule is harder than ever. Leading engineering teams rely on Instrumental to find issues earlier, fix them faster, and make sure they don't come back. Experience the first manufacturing optimization platform designed to enable continuous improvement of your process, from development through production, by unifying your data so your teams can make decisions faster. Instrumental makes finding correlations in product data easy, so your engineers can spend less time wrangling data across email, spreadsheets, and internal systems, and more time solving problems. It's simple. We put the right data in front of the right people in real time. Instrumental aggregates images of every unit at key assembly stages, parametric test data, and measurements in real time in a secure, managed cloud. When installed across factories in a supply chain, brands and suppliers are able to work together to solve their most complex issues. From your first build, Instrumental's Discover AI proactively identifies new issues by scanning your products for anomalies and automatically delivering a daily queue of issues. Engineers can jumpstart failure analysis with defects in context. Engineers leverage a rich, remote dataset to quickly identify correlations and potential root causes, and can push live tests to validate solutions immediately. They use Instrumental to eliminate issues at the source and make sure they don't come back. With complete build and issue analytics for the entire team, program leads can kickstart daily stand-ups, streamline executive reporting, and communicate seamlessly with global teams. Instrumental has helped leading engineering and operations teams move faster, improve yield, and build better products from proto through production. Better products start with better data. Better products start with Instrumental. Schedule a demo today.